Hi everyone, I am Beena, Faculty of Computer Science at Silver Hills Public School, KOZHIKODE. Today we will be discussing about one of the important topic in class 12, that is Q. In part 1 we have discussed about stacks. The concept is clear to you. Okay. Now we will move on to Q. Actually, what is a queue? We can see queue everywhere, that is in front of ATM, bank counter, fee counter, in supermarket, everywhere. Okay. Now just to go through the diagram. Those who are in front of the queue will be served first, followed by the second person, followed by the third one, and those who are entered into the queue at the end will be served at the last only. Therefore, what is a queue? Queue is a compound data structure that is comes under linear data structure which follows first in first out manner. That is, first person will serve first, followed by the second one, then followed by the third one, and those who are at the end of the queue will be served at the last only. That concept is known as a queue. Okay. Now we will move on to one animation that explains how the queue is working. Now first one entered into the queue. Queue is having two pointers, one is front and the second one is rear. Since only one person is there in the queue, both are pointing at the first person. Now one more person entered, now he will become at the end of the queue. One more person entered, now rear moves to that position. One more person entered and the rear moves to that position. Therefore, queue is having two ends. First one is front end and the second one is rear end. And from where the deletion take place, that is from the front part. First person in the queue will serve first, followed by the second person. Now when this last person is served at the end only, that is why I told you queue follows FIFO data structure, that is first in first out. There are mainly two operations associated with a queue, NQ operation and DQ operation. Okay. Now this is an empty queue. Okay. As I said earlier, there are two pointers associated with a queue, that is rear and front. Initially, the rear and front is pointing to somewhere else. Okay, for example, it is -1. Now I added one element, for example 10. Now the rear end and front end both are pointing to this location, that is rear is equal to 0, front is equal to 0. What is the reason? We are using a list for maintaining a queue. Therefore, list is having index, that is the first index is at place 0. If there is only one element in a queue, the rear end and front end will be pointing at the same place, that is at the 0th place. Now let us see, I added one more element, for example 20 to the queue. Now what will happen? Front will be pointing at the same place. Now the rear will be pointing to the end, that is to the element 20. Now I added one more element, for example 30. Now rear is moving to this place. Okay. Now I added one more element, now rear is pointing to this location. Now from this diagram we can see that front is pointing at the element at 0th place and rear is pointing at the element at the 3rd place. Okay. Now let us see how the deletion or DQ operation is working. Suppose I deleted this element 10, what is happening to the front? Now front will be pointing to this location. Suppose I deleted this element, now the front will move to the index 2. Now I deleted this element, now the front will move to this position. That means when the front and rear is pointing at a particular location, the meaning is that there is only one element in the queue. Okay. Now, suppose I deleted this element 2. What will happen? Now there are no more elements in the queue, therefore the front and rear will be pointing to somewhere else. It can be a -1 or something like that. That means now when you suppose that you are trying to display any of the element in the queue, it will cause an underflow situation. That means there is nothing in the queue. Like a stack, queue is also a linear data structure that follows FIFO manner. And in queue, we can add elements at the end of the queue and we can delete element from the front of the queue. That is why I told you there are two operations associated with a queue, NQ operation and DQ operation. Okay. NQ operation means add an item to the queue. If the queue is full, we can't add any more item, that will cause overflow situation. And in DQ, there is a situation known as underflow. If nothing is there in the queue, that is when the queue is empty, and if we are trying to delete an element from a queue, that will cause underflow condition. Now let us see how we can implement a queue by using list. You can relate it with the same thing with the stack. We had studied how to implement a stack using list. Same thing we can use it here also. Just compare stack and queue. In stack and queue, elements are added at the top. But in queue, the element is deleted from the front. That is only the difference between stack and queue. Now let us go through this. The main operations associated with the queue are, first we have to create a queue, that is an empty queue. Next we have to study how to insert element into the queue. Then we have to study how to perform DQ operation, that is deletion from a queue. Then the last one is queue traversal, that means how we can display all the elements of a queue. Okay. We will move on to first one, that is how to create a queue. Okay. Here also we can have a square bracket, that is object is equal to square bracket. This we have studied earlier, how to create an empty list. Here queue is a variable of type list, it is an object. And similarly, you can write one more command either this way or this way. Queue is equal to list. List is a function which is used for creating an empty list. Okay. This way you can create a queue. Okay. Now we will see how we can insert an element inside a queue. We can have a insert function. Def stands for function definition. Now insert is a function which is used for inserting element. Before that we can declare a variable or object q is equal to empty by using square bracket, which means that q is a list itself. Now again there is a function or a method append which is used for adding elements at the end of a list. Same function can be used here also. Append function for adding element, q dot append of, you can ask for entering a number. If you find any difficulty here, what you can do is, you can write here n is equal to input enter a number. Then instead of this statement or command, what you can write is q dot append of n. That is, if it is easy for you, you can do like that. Then you can have a message element inserted. So simple. The queue operation is so simple, only this much you have to study. Now let us see how we can delete an element from a queue, that is the DQ operation. Here also there is a particular function or a built-in function associated with the queue, that is pop. And what is the difference between stack operation and queue operation is, in queue we can delete only from the front, but in stack the deletion is from the top. Here in stack we had used the command just pop only, but in queue we have to use the command q dot pop of 0. 0 stands for the index and the element at place 0, that is first element of the queue. Therefore, in order to perform this delete operation, first you can have a function delete. You can check whether the queue is empty. If the queue is empty, as I said earlier, you can have the message, it is an underflow situation, deletion is not possible. Otherwise, you can delete the first element from the queue by using the built-in command q dot pop of 0. Okay. Now, I think this concept is clear to you. This is also very simple concept. If you want to check whether the queue is empty, there are so many methods. In first method, you can check whether the queue is empty by using a square bracket. Q is equal to square bracket. It will check for whether the queue is empty or not. And second method is you can write the statement or you can write the command if not queue. That also stands for whether the queue is empty or not. Okay. Now, the third method is you can find, same as that of stack, you can find whether the length of the queue is 0. If the length of the queue is 0, you can have appropriate message, underflow, deletion is not possible. Okay. Now, we will move on to queue traversal. Traversal means, as I said earlier, visiting each element of a queue. It is known as queue traversal. Okay. Now, in queue, the indices are like this 0, 1, 2, 3, 4, 5 and there are 6 elements in the queue, and in front of the queue the element 10 is there, and at the back of the queue the element 100 is there. Okay. Now, you can start printing from 10, then followed by 60, 50, 25, 70 and 100. For that, you can code it like this. You can have a display function, def display, that is there is a function for displaying the queue. Then you can have the for loop, you know how to use for loop. You can write it for I in range of length of queue, because the printing starts from the beginning, that is 0 index onwards. Now, this will substitute the value. Suppose that the length of the queue is 5, then range of 5 means 0, 1, 2, 3 and 4. The elements and index positions 0, 1, 2, 3, 4 will be printed. Okay. This way you can print all the elements of a queue. Okay. Now, let us see how we can write the entire program together. Implementation of queue using list, how we can write the entire program. First, you can create an empty queue. Okay. Then you can have the insert function where you can write append command for adding element to the queue. Okay. Followed by delete function where you can find out the length of the queue, then you can write it appropriate message, followed by queue.pop of 0, which is used for deleting the first element of the queue. Now, next you can have a display function for printing all the elements of a queue. Next you can have the main program where you can have all the options like insert, delete or display, or you can write it enqueue, dequeue and display instead of this. Okay. Then you can have your own choices. If choice is 1, then it will invoke insert function, that is given in the front. This function will be invoked. Okay. Now, if the choice is equal to 2, delete function will be invoked. Choice is equal to 3, display function. Other than any choice, you can have a message like wrong input. Now, this program will execute until your choice is no. Otherwise, until the condition becomes true, the program will execute again and again. This way, you can implement the concept of a queue. In part 1, we have discussed about stack, and in part 2, we have discussed about queue. I think the concept is clear to you. Thank you.